Hello, today we will try to solve our qualification round for the math tournament that we had on Friday. Not everyone solved every problem, so we need to talk about that. So we'll start with number one. We are given a matrix with numbers from 1 to 10, and we need to find the square of this matrix, meaning we need to multiply matrix A by matrix A, and we need to find the sum of all elements in the resulting matrix. So let's start to multiplying our matrix. So we will start with the first row and we will try to multiply it by all 10 columns, and we will try to find the total sum of the first row of A squared. So we will multiply 1 by 1 in the first, then 1 by 2 in the second column, 1 by 3 in the third column, and etc. 1 by 10 in the 10th column. Next, we will multiply 2 by 10 in the first column, 2 by 1 in the second column, 2 by 2 in the third column, and so on, 2 by 9 in the last column, and so on. 10 times 2 times 3 times 4, etc. times 1. So everywhere we will have sign plus, summing all of them to get the sum of 10 elements in the first row of A squared. We can see that every row here in what I wrote has the same one common number. So if we take this common number, we will be having the sum of the first 10 integers. Then we have the same thing with 2 and etc. with 10. So this sum is equal to 10 times 10 plus 1 over 2, which is 55. So we have 1 times 55 plus 2 times 55, etc. plus 10 times 55. Note that we only now counting the sum of the numbers in the first row of A squared, not in the whole matrix. Now we have common multiplier of 55, so we have the same thing, which is 55 squared, or just 3025. So you can find the sum of these numbers. Now what we do, we have to look at the second row. When I will try to multiply the second row of A on all of the 10 columns of A, I will have the same situation. Numbers rotate, but they are the same numbers. So I will have the same situation 10 times. So the sum of all elements in A squared will be 10 times, it's the number of rows, 3025, which is the sum of elements of one row. So it will be 30,250. So this is the solution of the first task. So we can move further. to the second problem. So here in the second problem, we have recurrent formula for xn, and we need to find the limit when n merges to infinity. So we need to find some algebraic form of xn, and we will use some method that we often use in these situations. We will use a characteristic polynomial. So we put xn as lambda to the power of n. So then we have this simple equation. As we see that numbers 5 and 4 are different, then just solution lambda equals to 0 is not fitting us. So we can divide by the smallest power, and we will get lambda squared equals 5/4 of lambda minus 1/4, or we get just equation like that. We can simply solve this and get 1 and 1/4 as roots of this equation. So the common solution of this will be some constant 1 times 1 to the power of n plus some constant 2 times 1/4 to the power of n. Well, 1 to the power of n is 1, so it's easy. How to find this C1, C2? We will use these conditions. So when x0, or C1 plus C2 is equal to 5, when n is 1, have C1 plus C2 times 1/4 equals 4. We just subtract these equations and get this one, or C2 is 4/3. And now we can find C1 as 5 minus 4/3, 11/3. So our xn is 11/3 plus 4/3 times 1/4 to the power of n. When I will try to find the limit here, I will have the sum of two expressions. So this second expressions will go to 0. So the limit is just simply 11/3. So this is the answer to the second problem. Now we move to the third problem, and here we have some function over some circle, and we need to find the maximum and minimum values of this function. We will use Lagrange method, so we will build. As we have only one condition, we need only one coefficient, so we will write 3x plus 2y squared, and then we will write plus this coefficient times this difference. After that, we will find partial derivatives of L. dl over dx is 3 plus 2 lambda x. dl over dy is 4y plus 2 lambda y, and dl over the lambda is just our condition. So all of them must be equal to 0. The gradient of L must be equal to 0. We can easily find x from the first one. So x will be minus 3 over 2 lambda. Here we will have in partial derivative over y, we will have two solutions. So one solution is y equals 0. Another solution is when y is not equal to 0, then we will have lambda equal to minus 1 or minus 2. And the third one doesn't need to be solved. We will try to solve it using this equation. So we will start with y equals 0. We will input it into the third equation and we will get x squared equals 8. So there are two solutions to that. X1 is minus 2 square root of 2. X2 is 2 times square root of 2. So there are two solutions when y equals 0. Now we need to count our f. So f from x1 and 0 will be minus 6 square root of 2. F of x2 and 0 will be 6 square root of 2. So we have that. Now we will move to lambda equal to minus 2. We will input it into x and we will have x is 3/4. Now we input it into our condition in the circle and we have 9 over 16 plus y squared equals 8, and y will be plus or minus square root of 119 over 4. Well, when we will input this into our f function, it doesn't matter if it is plus or minus, because y is squared, doesn't matter anyway. So f of 3/4 and square root of that will be 9 over 4 plus 2 times 119 over 16. So 9 over 4 plus 119 over 8. 18 plus 119 over 8. And this is just 137 over 8. Well, 137 over 8 is more than 17, so it's the largest value. So maximum value of x will be 137 over 8, and minimum value of f will be minus s square root of 2. So this is the solution of the third problem. So now we can move to the fourth problem. Here we need to find the volume of the figure enclosed between z, plane z equals 0, and in subspace y is non-negative. So I've seen the solutions when you tried rotation over about the OZ axis, but it's not correct because the coefficient at x is not the same as coefficient at y. So when you draw this thing, z and x, will have such view, and when you draw it with z and y, the graph will be different. So as you see, points 4 are the same, but the width of the parabola is different. So you cannot get this from rotation. So what you need is to calculate the integral, double integral, with conditions that we have. We will do this over x and y. So we need the z maximum value. We have, this is the boundary when we apply it as z equals 0. The boundary will be 4 minus 2x squared minus y squared. So this must be for z non-negative, so it must be greater or equal than 0, and y must be greater or equal than 0. And here we will have our formula for z, just the function of x and y, dx dy. So if you will try to solve it like that, you will have some problems, because you will get square roots, and integrals of square roots are not so easy to solve sometimes. It takes much time. So we will need another substitution. We will use this form of substitution. AR cosinus phi, and y is BR sine of phi. So this substitution, if you have an ellipse using x and y, you can easily build this. So what is A, what is B for our thing? So A and B are got from this equation of the ellipse. So we see that we have 2 in front of x squared, so we will have x equals r over square root of 2 cosine of phi, and y will be just r sine of phi. Now we need to calculate the Jacobian. So we need dx over dr, which will be cosine phi over square root of 2. We need dx over d phi, which will be minus r over square root of 2 sine of phi. We need dy over dr, which will be just sine of phi, and dy over d phi, which will be r cosine of phi. And we need to find the determinant of this matrix, and this will be our Jacobian. So we have r over square root of 2 cosine squared of phi. Then we need to subtract the sine phi times minus r over square root of 2 sine phi. So we'll have this thing, and minus to minus we'll have plus r over square root of 2 sine squared phi. Cosine and sine will give us 1, so we have just r over square root of 2. So now we can write our integral using this substitution. So we have r from 0 to pi from 0 to pi. Y from 0 to pi because we need only non-negative y, and y is non-negative when sine of phi is non-negative, and it's non-negative from 0 to pi. And now we substitute our values, so it will be 4 minus, so instead of x squared we will write this thing, r squared over 2 cosine squared phi minus, instead of y squared we will write our substitution, r squared sine squared phi. Then we need to write the Jacobian, which is r over square root of 2 dr d phi. Now we have something different than we had before. We can get our square root of 2 here. This cancels. Cosine phi and sine phi whole squared will give us 1 again. And we have r from 0 to 2, phi from 0 to pi, 4 minus r squared times r dr d phi. So this is way easier. We see that we don't have any phi inside our integral function, so we can already calculate the integral. So it will be phi over square root of 2, r from 0 to 2, 4r minus r cubed dr. And we can calculate this one integral. Phi over square root of 2. Then we have 2r squared minus r to the power of 4 over 4. And r will be from 0 to 2. So we don't need to substitute r equals to 0 because it will turn everything to 0. We need only to substitute r equals 2. 2 squared minus 2 to the power of 4 over 4, which we can solve. So here we have 8 minus 16 over 4 is 4. So we have 4 pi over square root of 2, and we get 4 pi square root of 2 over 2, or 2 pi square root of 2. And this concludes our qualification round. This whole solution is what you had to do. And that's all.